In this video, let's start few problems based on whatever topics we have learned. All right, look at the first one. See, we have for the first one 1 plus 3 square till 3 power n minus 1 is 3 power n minus 1 by 2. Correct? So, what do we do? In the first step, you can say p of n is equal to 3 power n minus 1 by 2. So, then we'll take let p of 1 which is equal to 3 power 1 minus 1 by 2. 3 minus 1 is 2. 2 by 2 is 1. So, p of 1 is true. Correct? This is the first part. Now, the second part is p of k. Right? So, in the second part, p of k, let p of k be also true. So, p of k becomes 3 to the power of k minus 1 by 2. Correct? So, p of k is equal to 3 power k minus 1 divided by 2. Correct? Now, we'll go for p of k plus 1. Fair enough? For p of k plus 1, see what do we have? P of k plus 1 is equal to 3 to the power of k plus 1 minus 1 divided by 2. Correct? This is what we need to prove. Now, let's start. P of k is equal to 1 plus 3 square, so on and so forth, 3 to the power of k minus 1. Correct? This is p of k, which we know is 3 power k minus 1 by 2. So, you add k plus 1, but it's not just k plus 1. It's going to be 3 to the power of, so on the LHS if I take, that means we are talking about this particular scenario. So, what do we add? 3 to the power of k plus 1 minus 1, isn't it? 1 and 1 cancels, 3 to the power of k. That means we are taking 3 power k and we are adding on both the sides. So, what we are going to get now? 3 to the power of k minus 1 by 2 plus 3 to the power of k. I hope this is clear. Remember, 3 to the power of k minus 1. So, the next term will become 3 to the power of k plus 1 minus 1. Plus 1 minus 1 cancels. It's just 3 to the power of k. So, we are going to add 3 power k on this side. Clear? So, let's start with the simplification of the last step, whatever we have written. What you have is 3 to the power of k minus 1 by 2 plus 3 to the power of k, isn't it? So, next thing what we can do, take LCM, 3 power k minus 1 plus 2 into 3 power k divided by 2. Correct? So, next what we do, 3 power k plus 2 into 3 power k minus 1 by 2. See here, between these two, you can take 3 power k common, correct? So, what do we get here? You will get 3 power k into 1 plus 2 minus 1 divided by 2, or 3 power k into 3. So, 3 power 1, isn't it? What is 3 power k into 3 power 1? Isn't it the same as 3 power k plus 1 minus 1 by 2? Isn't it? So, don't you think this is the value of p of k plus 1? So, what did we prove now? The final conclusion part you have to write. See, for the conclusion part, what you have, p of k plus 3 to the power of k is equal to p of k plus 1. We just proved it. This implies p of k plus 1 is true. Therefore, p of n is true. So, p of n is true. Now, this is going to tell us that the p of n, whatever the formula we have, it's true. Okay, so this is the Very first question. Now let's do the second one. See the second one. 1 into 2 into 3 plus 2 into 3 into 4 plus so on and so forth till n into n plus 1 into n plus 2 is equal to something. Okay, so we have this. It's quite a big problem. In the sense, it's quite lengthy, isn't it? So let's start. Very simple. We'll start with the first step. That is, let P of n is equal to n into n plus 1 into n plus 2 into n plus 3 divided by 4. Correct? Let P of 1 be true. So we'll first have to show it. So P of 1 is equal to 1 into 2 into 3 into 4 divided by 4, which is nothing but 1 into 2 into 3. The very first number is 1 into 2 into 3. So P of 1 is true. Well and good. No issues. The second step, what we are talking about, let P of k be also true, right? And P of k is given by k into k plus 1 into k plus 2 into k plus 3 whole divided by 4. This is P of k, right? Now, third step we are going to talk about. This is a quite important step. So you can say P of k plus 1 is equal to k plus 1 into k plus 2 into k plus 3 into k plus 4 whole divided by 4. This is P of k plus 1. Now we need to prove that P of k plus 1 is true, isn't it? So let's start with the math now. See what we have, 1 into 2 into 3, so on and so forth, correct? So we have 1 into 2 into 3 plus so on and so forth till n into n plus 1 into n plus 2. Or if you take in terms of k, then what we are going to have is instead of n into n plus 1 into n plus 2, so we are going to have k into k plus 1 into k plus 2. Correct? So this is P of k. Though we know P of k is true. So this is equal to k into k plus 1, k plus 2 into k plus 3 whole over 4. Now for the LHS and RHS for both the cases, what we are going to do, we have to add the next term, isn't it? See, next term for k, it's going to become k plus 1. For k plus 1, it's going to be k plus 2. And for k plus 2, it's going to be k plus 3, isn't it? So we are going to add this k plus 1 into k plus 2 into k plus 3 for both LHS and RHS, correct? So we are considering only the RHS part. So for the RHS part, you will get k into k plus 1 into k plus 2 into k plus 3 whole by 4 plus k plus 1 into k plus 2 into k plus 3. Now, before you take LCM, you can do by LCM method also or taking out common now itself. Very simple. So, I would rather take common first. So, you will get k plus 1 into k plus 2 into k plus 3. This is common into k by 4 plus 1. Right? Guys, don't worry too much about what is outside the bracket. Worry about what is inside the bracket because that is where the entire problem is going to rely on. So if you are considering only what is there within the bracket, okay, taking the LCM is going to give us, remember I'm talking only within the bracket. So what you have here, only that much. It's going to become k plus 4 divided by 4, isn't it? So overall, if you write, you're going to get k plus 1 into k plus 2 into k plus 3 into k plus 4 whole divided by 4. Isn't this same as p of k plus 1? Correct? So what we just proved is p of k plus 1. So let's write down the conclusion. Conclusion part. So proved now. P of k plus the next term, that is k plus 1 into k plus 2 into k plus 3 is nothing but P of k plus 1. This implies P of k plus 1 is true. Therefore, P of n is true. Therefore, P of n is true. Very, very simple. This is the second problem. All right. Let's do the third one now. See the third one. What you have is same thing, guys. 1 into 2, 2 into 3, 3 into 4, like this, correct? Now, I want you guys to solve it. Yeah, go ahead, pause, solve, then check what are steps you have written is right or not. Check the correct answer. All right. Go ahead, pause, solve. I hope you guys got the answer. Now look at this one. So in the first step, P of n is equal to n into n plus 1 into n plus 2 divided by 3. Correct? Then let P of 1 be true. So P of 1 is equal to 1 into 1 plus 1 is 2, 1 plus 2 is 3 divided by 3. So it's nothing but 1 into 2, which is the first term. Yes, so P of 1 is true. Next, second step, P of k, let P of k be also true. Correct? And P of k is equal to k into k plus 1 into k plus 2 divided by 3. This is the value P of k. And in the third step, we say P of k plus 1 plus 1. This will be equal to k plus 1 into k plus 2 into k plus 3 whole divided by 3. We need to prove this, right? Now, so the next step what we have is we need to prove it. Let's start with the next part. You have is 1 into 2 plus 2 into 3 till k into k plus 1. So this value is nothing but k into k plus 1 into k plus 2 divided by 3. So we are adding the next term, isn't it? So for k, next term will be k plus 1. For k plus 1, it's going to become k plus 2. Correct? So what are we doing is we take k into k plus 1 into k plus 2 by 3. Remember, we are always talking about RHS. For this, we add k plus 1 into k plus 2. Take common, just like the previous sum, no difference. So we'll have k plus 1 into k plus 2 into k by 3 plus 1. Again, only concentrate on what is inside the bracket. So if you write this one here, you will have k plus 3 divided by 3, after taking LCM. So what do you get? K plus 1 into k plus 2 into k plus 3 whole divided by 3. This is nothing but P of k plus 1, what we did in step 3, isn't it? So what do we have the conclusion now? That P of k plus k plus 1 into k plus 2 is equal to P of k plus 1. So this implies P of k plus 1 is true. Therefore, P of n is true. So P of n is true. So these are 3 questions. Okay, these are the one type. In the next video, we will see and solve few more problems based on induction.